So, welcome everyone. I can just add that even though you will not get any slides, you will get all the data and queries that will be used for the demo, so that all of the things you're going to see, you can try yourself later.
Oh, that's cool. Yeah, I missed that point. Thank you.
Yeah.
Good at.
Okay, so, and I can only add that I saw that a lot of people haven't used GraphDB before. So for them, I guess the most interesting part will be the new interactive guides. So if all of the things that I'm talking first are confusing, please bear with me, because at the end, I will show you something that will hopefully introduce you to GraphDB in a nice interactive way. So since GraphDB is a database, one of the first things that you want to do in order to actually do anything meaningful with GraphDB is to create a repository. So I'm just quickly going to create a repository. It's not something I'm going to focus on. And then the first part of the demo will focus on the new SPARQL functions. It's a lot of different functions. We are not going to cover all of them because many of them are simply too boring to bother to show in a demo. And so we're going to look at those that are in a way unique and useful, because there is no other easy way to do what they do. So first of all, I will need some data in order to show you some things. So the data is very simple. It's just a couple of people. So it's Robert, Elizabeth, John, and Mary, and each of them is of type person, and each of them has a list of nicknames, and the nicknames are modeled here using RDF lists. And if you've seen RDF lists before, you know that they are very convenient to describe things, but they're kind of difficult to use because, so for example, if we look at this list here, what you get in the database is a bunch of triples that describe the list as a series of triples as a linked list using the RDF first and RDF next predicates. So in order to do any query with the list, you actually have to use those predicates instead of this convenient shorthand that we see here in SPARQL. So I just inserted the data. As you can see here, 66 statements have been inserted, which tells you that obviously here it's not 66, but as I said, those lists were expanded using the RDF first and RDF next notation. So the first set of functions have to do with using lists, RDF lists in SPARQL, and those functions are actually modeled after the corresponding functions in Jena. We decided to simply implement equivalent functions because if you've already used Jena and you know those functions, you might have SPARQL queries that use them. So you just want to take those queries and use them with GraphDB, and they will work out of the box. That's the reason we simply reuse the function definitions. So the first function is called list length, and it will give you the length of the corresponding RDF list. So here we select each person, the nicknames of that person, and then on this variable here, nicks, we apply the length function. So those functions are not functions in the classical SPARQL way. They are used as magic predicates in SPARQL, so they look like data. And if I execute this SPARQL query, I get, as a result, all the persons as well as the length of their nickname list. And we can see that Robert and Elizabeth have many more than John and Mary. The next list function is the list index function, and it allows you to either get the index of something in the list, namely find that the position of something in the list, or get a particular element in the list that's at a predefined position. So in this example here, we use variables in both positions. So if I execute this query, I get, for every person, I get the index of every nickname as well as the corresponding nickname. So Robert, I think, had 10 nicknames, so the indexes are from 0 to 9, just like in many programming languages, indexes are zero-based, and then all the nicknames. And since this is SPARQL and these are variables, we can, for example, if we put 4 here, we'll get the fourth position of the fourth nickname of every person. So you now see that there are only 3 of them here, just because I think John had only 3 nicknames. So there is no such position, so we don't get the result. And just like that, we can also look up which of those has a nickname Bob and what's the index of that nickname. And if we execute it, we see that Robert has that nickname and it's on the 2nd position in the RDF list. And the last RDF list function is the list member function. And it's an easy way to test if a particular list has a given member. And if we just use a variable here, it will enumerate all the nicknames for the provided person. So we select all the persons and then for every person the nicknames, and then we list all the nicknames. And just like in the other functions, we can replace this with a constant and see which person has the Bob, the provided string Bob as one of their nicknames. So list member is in essence a shorthand notation of list index where we don't care about the index. So let's move on to some other functions. Here we again use the list member function in order to get the nicknames, but we also use 2 other functions, sprintf, which is sprintf is a function that you will find in practically every programming language. It might be called slightly different, but every programming language has an equivalent functionality, and it allows you to specify a template with placeholders such as %s, and then fill this template with actual values using other arguments of the function call. And the other function here is local name, which takes an IRI as its input and returns the local name of that IRI. So if I run this function, I get the persons in my data, the nicknames, and I built a new string which produces a sentence in English. Robert has a nickname Bill, Robert has a nickname Billy, and so on. Okay, and the last function that we are going to have a look at is the str split function, and it allows you to split given string with the provided separator. And again, this function, just like the list functions, is not a classical SPARQL function. It's used as a predicate, and that's very convenient because if it's used as a predicate, it can produce more than one output. So obviously here in this string, John, Mary, Robert, Elizabeth, we're splitting by comma space, and so we want all these values that we have in the string as individual values. And then we will bind to the x variable, and then using that variable, we construct an IRI, and we can do this because we have specified the base IRI. Otherwise, I would have had to use concat in order to produce my IRIs. And also here we have a short IRI using the base, and using this, I'm able to construct from a single literal, I'm able to construct new SPARQL, new RDF data, namely from the names that are contained in this string. I was able to construct IRIs and then produce triples using those IRIs. Okay, so let's move on to the oh, sorry, there are a couple more functions that I want to show you, but for that I will need to load more data. So I'm importing a data set called Star Wars API. It is a data set that we use in the documentation and as demo for some of our other products. And occasionally I use it for GraphDB demos because it contains a lot of easily understandable things. And you'll see that data set also later in the interactive guides. So now that my data is imported, I go back to the SPARQL editor. And in this data set, it obviously has to do with Star Wars. We have characters, planets, the Star Wars movies, and a lot of things and information about them. So in this SPARQL query, I select all the planets that are in Star Wars, their names, their diameter, and their population, and I compute a simple metric density by dividing the population by the diameter. And if we have a quick look at the list, we also notice that for some planets we have zero size, even though we have some population, and which is a bit unexpected. So this could be either an error in the data set or some other anomaly. And we also have one planet that has zero population, which is perfectly fine. We have a lot of those in our solar system. And the functions that we are going to use are the new aggregate functions. So classical SPARQL, standard SPARQL 1.1 has a bunch of aggregate functions such as average, sum, minimum, maximum, and so on. But it lacked some of the functions that were that have been in SQL databases for years, such as functions for the standard deviation, the variance, and such things. So again, here we decided to simply use the notation and function definition that was used in Jena, simply because we want to make it easy for people who have used Jena before, if they want to switch to GraphDB, to not change too much. And so in this query, we use those functions. They are used just like the SPARQL standard aggregation functions. And as you saw, we have some planets without the population or without the diameter, so we want to filter those out in order to not skew our result. And here we compute the standard deviation of the diameter of the population and the density, as well as the variance of those parameters. And we also have an average. So average is an example of a normal SPARQL aggregation function. So as you can see, they're used in pretty much the same way as the standard functions. And if we execute this, we get the result back. And obviously, if you don't work with numbers, this is very boring. But if you work with numbers, it could be potentially interesting. And what we can immediately tell is that if we look at the standard deviation of the diameter, it's kind of a not very big number. So it's 18,000 something. And if we look at the standard deviation of the population, it's a much bigger number. So this here is 1.7 to the 10 of the power of 11. So it's a much bigger number. And this tells us that the diameter of the planets doesn't vary that much in the population of planets, while the population of the planets varies considerably more than the diameter. And this is, again, something that's not totally unexpected when you have planets and some of them are populated, some of them are severely overpopulated, and some are quite underpopulated. So that was everything about functions. So let's move on to the full text search. And for the full text search, I'm going to create a new repository, because in order to use full text search, I need to enable it in the repository settings. So you have to click here, and then you have to decide which of the full text search indexes you want to build. So if you are unsure, we also have described how to choose those based on standard use cases in the documentation. So in today's use case, I'm going to use the same Star Wars dataset. And since we have multilingual data, so we have the names of the movies and some other things in more than one language, I'm going here to simply list a bunch of languages, as well as the IRI index. I'll go back to the IRI index a bit later. And so this is the list of the indexes that I want to be enabled and updated. And with this setting, I say what happens to those literals that don't have a language. So it's fairly common when you have RDF that much of the data that's actually in English is in English without being tagged specifically as an English literal. So we want to treat those tagless literals as being in English by setting this. So that's my new repo, and I'm going to import the same data set that I imported before. That's the Star Wars data set. So the data is being imported and indexed for full text search. And so in its simplest form, the full text search is done by using, again, a magic predicate, just like the list functions and some of the other functions you saw. It's the Ontotext FTS predicate. And if you provide just a string here, it will search in the default index. So the default index is English. And here we see that, so we are searching in the object position of the triples that we are selecting. And our full text query is just leader. And if we look at the text, we see that we have leader here. And in some of those, in all of those texts below, we also have leader. And what about narrowing down to, if we look here, we see that it says droid leader, blah, 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 and then kidnapped Chancellor Palpatine. And we can change this to a query like this. So I added the word kidnap because I saw kidnapped here. And I added the pluses because when you specify a plus, it means I definitely want this word to be there. While if it's without a plus, it means this word could be there. So when I had a single word, obviously it has to be there in order to return any results. But when you have more than one word and you want all of them, you have to do it like this. That's the standard Lucene full text search notation. And if I execute this query, I get just this single literal that we saw first. And because this is full text search, as you can see here, I entered just kidnap, while the actual word that's in the text is kidnapped. And that's because this is the way full text search works normally. For every language, there is a particular analyzer that is used to index the word such that when you search, it finds not only the string that you entered, but also words that are another form of the same word. So if we move on to the next search example, it uses another index, namely the index for German. So if you remember, when I created the repository, I listed a bunch of languages, and one of them was German. So DE is the language code for German. And so if I execute this, it will search only in those literals that were tagged as German in the RDF dataset, and it will use the German analyzer in order to find different word forms. And here I have the string das Beste, which means the best. So one of the ways to say the best in German. And some of the results are results that I expect, such as here we have Oscar für den besten Film, which means Oscar for the best movie in German. And then a bunch of other Oscars for the best whatever. But also here in the beginning, I have two names, Ahmed Best and Lian Best. And that's because full text search will simply give you a match without taking into consideration if it's actually a proper name or just a normal word. And if we comment this and then uncomment one of the other ones, so in this particular case, we search in the Spanish index. So ES is the language code for Spanish. And the word is películas, which means movies in Spanish. And if we execute this and we scroll down and look at the results, we see that a lot of matches are indeed película, which means movie. And if you're observant, I'm not sure if you can see this. I'll try to enlarge the screen. So as you can see here in the results, the I has an accent mark, while here in the query, it's just a regular I. And that's again a feature of the corresponding language analyzer that will deal with the diacritics such that you can find things in an easier way. And besides the singular form película, we also have películas somewhere down here, just like we enter it in the query. And the next example is in French, and it's so I can pronounce French that well. So Oscar acteur or something like that. And if we execute this, we get a number of results. And as you can see, acteur is exactly what we have in some of these, but in many of them we have actrice, which is an actress. So acteur is the masculine form, and actrice is the feminine form. Again, the language analyzer did this for us and allowed us to find all these matches. And finally, if we uncomment the last one, that's migliore in Italian. And if we execute it, in the results, again, we get a number of different forms of that word. So miglior here, and migliori here, and migliore here. So that's how the language indexes work. And finally, when it comes to full text search, if you remember, I enabled, besides the language indexes, I enabled an index called IRI. So this IRI index is a bit special because it's not a classical full text search index, because it only includes IRIs, and those IRIs are not analyzed in any way. So they're treated as one single piece of text. And this type of indexing allows you to find an IRI by specifying a prefix. And here we have a SPARQL query that selects persons having the type character. So in our data set of Star Wars, all the different characters, which are not only persons, but also droids, have the type character. And we also want them to have a second type. And this second type, by using the FTS index for IRIs, we want the second type to be something that starts with this. So the star characters means that everything after HTTPS, SWAPI, co vocabulary, capital T can be anything. And we also select the labels of those characters, and we also want only those names that don't have a language tag. And if we execute this, we get a bunch of characters, so persons, and we get their secondary type, which is a particular kind of alien. Because if we put H here and we execute the same, we get a bunch of humans as expected. And with H, we also have one single other match. It's Hutt for Jabba the Hutt. So I never knew that Jabba the Hutt's name is Jabba Decilegic Diure or something like that.
That's news for me as well.
Yeah, so it's a very cool data set for all kinds of things. So that was everything about the full text search, and we can move on to the interactive guides. So now is the time for those of you who are new to GraphDB. Very often people get interested in GraphDB because they read an article or they attended the webinar. I don't know, there is a reason always when you download something. But if you're not familiar with that particular software, it may be confusing at first on how to do things with it. So we decided to, of course, there's the documentation, but let's be honest, not many people want to read a long piece of text in order to do things. So we decided to create a system of interactive guides that's embedded in the workbench. So when you start GraphDB, this is the first screen that you see when you open GraphDB in the browser. And so this big orange button here is the easiest way to get to the guides, but another entry is through the help menu and then interactive guides. So I'm just going to click this button here. And as you can see, there are two guides. One is the Star Wars guide and the other one is the movies database guide. And in order to start the guide, you can simply click here. So I'm starting the Star Wars guide. And the first screen is always this introduction that tells you that this is the guide and how it's going to work, and gives you helpful hints on these little windows that you will see throughout the guide. So this, for example, is a box that provides information, as you can see here. So in those, you can only click the next button. And then the Star Wars guide. So actually both of these guides are beginner's guides because this is the first time we're doing those and we wanted them to be accessible for everyone. But in the future, we also plan to have more advanced guides that don't show you the basics, for example, how to create a repository, how to import data and so on, but instead of that focus on more advanced topics. So I'm not going to go through the entire guide or maybe just skim quickly through it. But the guides start with creating a repository. And as you can see, these little windows, when they open and you have to do something, only that part of the workbench is active. So I can't click, for example, here. I can only click inside here. And so this guides me to how a repository can be created and even suggest what I name my repository.
Mm-hmm.
And then shows me how to connect to my repository. And then it shows you how to enable the autocomplete plugin, because that's something very useful to have enabled if you use the workbench a lot to write queries manually or explore things and so on. And whenever you have to wait a bit, it will tell you to just sit back. Yeah, it's done. And so you already saw me importing files, but here as part of the guide, it will tell you to download the data. So if I just download this and then click next and then click upload, I can, that's strange, so let's try again. I can select the file I downloaded and then just import it. And then, so that's how the guide starts with creating a repository and then downloading something and then importing that data. And then here is where the two guides start to look different. So in this particular guide, the focus starts with exploring things visually, because if you're new not only to GraphDB, but also to RDF and SPARQL, then it's maybe not the best way to take you straight to the SPARQL editor and show you something that you don't understand quite well. So this guide starts with exploring things in a visual way. This is by going to explore and then clicking visual graph. And then because one of the steps earlier was enabling autocomplete, now it's very easy to find things. So here, for example, if I entered LU, one of the matches is Luke Skywalker. And so I can click here and the visual graph is initialized with Luke Skywalker in the center. So I'm not going to talk about what the visual graph is, because that's kind of the point of going through this interactive guide. So I suggest, if you're new to GraphDB, to do the guide yourself instead of listening to me what the visual graph is. So that's why I'm not going to explain what we see here that much. And so the guide takes you on to the visual graph, shows you different things, explains what they are in terms of the actual data that you see on the screen, such as here that Luke Skywalker is a character. And shows you how to do actions. For example, when you click on a node, you get more information here. Shows you, explains what these things are and how to interpret them. And here is a fun fact that a lot of people know, so it's not as obscure as the real name of Jabba the Hutt, is that this movie was released in 1977, and it's actually the first movie to be released. But in the Star Wars world, it's the fourth movie, because that's how George Lucas sees them, and also the story is told from this perspective. So the first movie was the fourth movie, and it was released first in 1977. And the guide goes on and shows other things, how to expand the visual graph, and when you expand it, you see more things, and how these things are connected. And that was the last of the visual graph, and then it moves on to SPARQL. And you already saw the SPARQL editor, so when you are in this interactive mode, it will explain different pieces of the interface and give you a query to actually use. And it shows you how to execute the query. Let me just move the window out of the way. And by clicking the run button, you get the results. And earlier, I think I didn't click the run button, I just used the keyboard, so that's possible too. But for the interactive guide, it shows you how to do things with the mouse, because that's usually more intuitive for beginners. And it shows several SPARQL queries, explains what they are, explains the results, and so on. And finally, that's the end of the guide. And an important thing to note here is that you can see here that were my queries that I used for all the other parts of the demo. And once I started the guide, it opened a new tab here. So you can open a new tab by clicking this button here. So that's the idea behind that, is that we don't want to mess up with any of your precious queries that you might already have in the SPARQL editor. And as I said, you can always go back to the guides through the help menu. So I'm not going to show you the other one just because it uses a different data set, shows slightly different parts of the workbench. So I suggest, if you're new, to actually start with the Star Wars guide and then do the other one as well. So that was everything I wanted to show you. Let me see now if we've got some questions.
Yes, we do. Quite some many, actually.
That's cool.
You can go over them and answer them one by one. We got about 15 minutes or so.
Question about the slides. There are no slides. This was a demo, but the data set and the queries that I showed you will be provided later. And the demo, the interactive guides are already in GraphDB, so you don't have to download anything in order to try those. Okay, quite a bunch of questions. So,
and yeah, they keep coming up.
Okay, there is a question: is there a limit on the number of repositories that we can create? No, there's no limit, but you should know that any repository that you use at least once since you start GraphDB remains active and thus consumes memory. So if you really have very many repositories, such as 100 or more, then it might be a problem. So a question on whether splitting a string adds those to the database or only on output. So this is a function that's used in SPARQL, so it's returned only as part of the SPARQL query, and unless you use it to construct data and then insert this data into the repository, then it will not get into the triple store. So functions don't modify the data in the triple store, they just produce output. Okay, which languages are supported for full text search? That's a very good.
The person is specifically interested in Dutch, if it makes.
Yes. So if I try to create a new repository now and I click enable full text search, there is a little tooltip here that gives you all the languages that are supported, and I think Dutch is one of those. Yep, NL, there it is. So the languages are all of the languages that are supported by Lucene full text search as part of the standard analyzers that come with Lucene. So, and the quality between those may vary quite a bit. So for some languages, it will be very good. For some others, it might not be exactly what you want, but for most of them, it should work well. Okay, there is a question on customizing how the full text search indexing works. For example, changing the tokenizers, analyzers, and so on. For the time being, in this GraphDB version, the only way to do this is by selecting a language and thereby a particular analyzer. In future versions, we will consider allowing a way to specify custom analyzers. So this will be a Java class that you provide in some jar file somewhere. And then when you create the index, you'll be able to specify what class to use for a particular piece of data. Separate indexes for different languages in the same group, such as Spanish from Spain and Spanish from Mexico? No, because that's kind of pointless. Just because the way full text indexing works, it does very crude stemming that there will be virtually zero difference between Spanish from Spain and Spanish from Mexico. Can you get a recording? Yes, there will be a recording. Do indexes slow down the load? Yes, any kind of index that you have in any kind of database means additional work that has to be done whenever you have an update. So, for example, if you have 50 languages in the dataset, maybe don't enable all of those for full text indexing unless you really want to search in them. Okay, that's a very good question. The question is kind of long, but what it asks is that it says that when you use this simple full text search, you get the literal back. And in order to find if this literal is in the right triples that you want to use, you have to use other SPARQL statements in order to do the join and fetch out the data. While this is compared to the Lucene and Elasticsearch connectors. And yes, if you need something more complex, then the connectors is the way to go, because in the connectors, what you index are actually entire documents. So for example, it won't be just a bunch of unrelated strings, such as, I think a very particular good example was when we searched in German. Need to go back to the other repository. When we searched in German, of course, there are things like Oscar for whatever best is one type of data, and then names of people is another type of data. And if you use the connectors, you'll be able to define very precisely the data, the shape of the data that you want to be indexed. And when you search, you'll get not the matching literals, but the matching documents, such as IRIs. So there is a note about that in the documentation. So if you're unsure if you need the simple full text search or the connectors, refer to those notes and maybe try both and see what works best for you. Okay, question about inference in GraphDB. I don't think we have the time for that, but you can have a look at the documentation. Question where to start if you're a complete beginner. I say give a go of the Star Wars interactive guide, and then if your interest is piqued, then maybe read about RDF and how to model things with RDF, and then how to use SPARQL. Using GraphDB to edit and design ontologies. So GraphDB can use ontologies that are already made by loading them into GraphDB, but for designing ontologies, you might want to use something else. Real experts actually use text editors to do that. They simply write RDF in order to define their ontologies. Other people use more visually oriented tools. And is it possible to perform full text search on virtual repos? And the answer is no, because virtual repos are essentially SQL databases and that are used to perform SQL selects and then return and convert the data to RDF. If in some way it's possible to send a string to a corresponding SQL function that does full text search, it might be possible, but it will in no way be related to this full text search that you saw today. The question if it's a wrapper around a regular Lucene connector or something separate, it's something entirely separate. Of course, both these simple full text search and the Lucene connector are based on Lucene, but they're separately implemented, have different features, used in different way, and other than being Lucene, there is nothing common between them. Okay, so I think that's all of the questions that we had the time to answer. Just have a quick look if there's anything else.
I have one. I'm not sure if you went over it about the use of this new feature of the full text search and the GraphDB connectors for full text search. What will be the difference? Which one should we use?
Yeah, I already discussed that. But in essence, the simple full text search, the object that you index is simply a literal or an IRI. And so the result that you get is exactly the indexed literal or the indexed IRI. While for the connectors, the objects that you index are actually documents, and these documents contain a bunch of triples that provide some relation. So for example, if this was Luke Skywalker from Star Wars, if we index Luke Skywalker, this will be an entire document, and you have Luke Skywalker, the IRI for Luke Skywalker, it will be the ID of the document, the name of Luke Skywalker will be inside the document, the planet where he lives will be there, there will be information that Darth Vader is his father, and so on and so on. And so searching within those things will always return the ID of the document, namely the IRI for Luke Skywalker, but not the matching literals that you are looking for. And the connectors are more difficult to set up because you have to describe this data model, what defines a document, but then they allow you to do these kind of searches that return, that make more sense in a given context. So it's all a matter of if you really need a simple full text search, namely find me that piece of data in the database that matches this full text query, then simple full text search is for you. If you need something a bit more complex, then probably you should look at
context dependent. Yeah, you should.
And the connectors also can do faceted searches and aggregations, which is something that you can do with the full text search in any way, with the simple full text.
Okay, thank you. I perhaps have missed it, but it's a good moment to repeat that. Okay, if we do have a couple of questions that were not the subject of the demo. I replied to them in private, and they require just a very specific answer that I will make sure I'll add in the follow-up email. And I think with that we can call it a night. I would like to invite you to, let me share my screen, to our next webinar that is actually hosted by oh, sorry, I'm just getting lost in the.
Okay, there is another question that just appeared.
Oh, okay, go ahead.
It's about if the simple full text search index is a local one and not distributed over multiple nodes for a cluster. So it's yes and yes. It's a local index, but if you're using the GraphDB cluster, then this local index will be present on every node in the cluster. Because the way the GraphDB cluster works is that every node has a copy of the data and a copy of the indexes. So the local indexes. If it was the Elasticsearch connector, there will be an Elasticsearch server somewhere, and so there won't be a copy on every GraphDB node. But because this is a local index, it will be on every cluster node.
Okay.
Yeah.
Thank you. Okay, then just use the 2 minutes to invite you to our next webinar that is hosted by the Semantic Web Company. It will be more of a look at knowledge graphs and specifically at the concept of knowledge hubs and how they differentiate from knowledge graphs, but from a more of a business perspective rather than a technical one. But yet, I wanted to, just make you aware of it. I will also add a link to the webinar registration page in the follow-up email. I wanted again to thank Pavel for doing this demo and going over these the new features. And I wanted to thank you for participating and for asking so many questions. Actually, it's always good to get the questions back, to get some questions back. It means that people are interested in actually listening. And I do have a little survey at the end of the webinar. Once you exit, it will just appear on a window. Just a couple of questions. It would answering them would help us improve the webinars, and we'll just get an idea of your experience of the webinar. And yeah, with that, I wanted to thank you. Follow up email with recording, data sets, and what else, Pavel?
The data set and the queries.
And the queries, yes, and the queries. Yeah, so a follow-up email with the recording, the data sets, and the queries, and some of the questions that haven't been answered tonight. You can expect that tomorrow. Okay, bye. Now closing. Bye. Thank you, Pavel.
Thank you too. Bye.